Okay guys, what we're going to do now is we're going to look at 8.5, which is graphs of power functions. Now, this is something that's going to be important to absolutely everybody next year, okay, whether you're doing Wiskunde A or Wiskunde B. As with most topics in this chapter, it's important for all of you. The really good thing is that if you get a good grasp of this year, it will make it much easier for you when we start it next year, okay? So, this goes for 8.5 and 8.6. Both of them are very important. All right, so when I say a power function, what I mean is a function in the form of fx equals a times x to the power of n. Okay, and this is our general formula. You'll notice there's no other terms. This is just one term for now. Okay, when we do 8.6, we'll look at more, but don't worry about that. So this is just a times x to the power of n. Okay, some examples of this could be fx equals 2x squared. Okay, that's a function in this form. We could also have gx equals minus a half x. Okay, remember, really there's actually x to the power of 1 here. All right, you can also have say hx equals minus 3x cubed. All right, these are all power functions, and we're going to look at them in more detail. To help us today, we're going to use GeoGebra again, because it really does help with this, being able to see the functions. Okay, so let's have a look. Firstly, I want to look at, firstly, the ones that have n as an even number. Okay, so for example, y equals x squared. Okay, you know that's a parabola. It looks like this. Okay, pretty easy. You've seen them a million times before. All right, if we make a negative, so for example, y equals negative x squared, okay, we get a nice one like this. Okay, great, it's reflected down. What I'm going to do now is we're going to ignore the down ones for the moment. It's important that you know about them, but I don't want to focus on them because I just want you to see what happens with the other functions for now. Okay, so let's turn that one off. We'll keep looking. Okay. We're not only going to be looking at squared and cubed anymore. Okay, we're going to go higher. We're going to look at the power of 4, the power of 5, the power of 6, etc. So you guys need to see what the general trend is if we change that power. So if I, for example, do x to the power of 4, what kind of function are we going to get? So that's something you have a little bit of a think about. Okay, maybe it will surprise you. Okay, because if we type in x to the power of 4 here, oh, it just looks like a normal parabola. Okay, so we have another parabola here, and you can see in this case that the corners, or I shouldn't say corners, but that base of the parabola becomes a little less pointy and a little more rounded. Okay, it becomes a bit more square. All right, but the arms become steeper. All right, and obviously again, if we have negative x4, it's going to be the same reflected down. Okay, let's try x to the power of 6. And there we go. So what you can see is x to the power of 6 is again fairly similar, but the corners are even more square. Okay, I shouldn't say square, but they're a bit less rounded. All right, if we go x to the power of 8, you can see that phenomenon happening again. It becomes more and more, it becomes closer and closer to being a square corner. However, it will always be slightly rounded. Okay, they will never be square. Okay, because that's not possible with these types of functions. Okay, and you can see those arms are becoming steeper and steeper. Okay, so this is a general trend with even numbers of n. Okay, so if n is an even number. All right, we're going to turn all of these off now, or I might even just delete them all. Okay, because you can see this is what happens with even functions. Okay, we're going to look at an odd one now. So, y equals x. You know that looks like this. This is y equals x. And remember, that's really x to the power of 1. It goes from negative on the left side to positive on the right side, and it's increasing the whole way across. So left to right, it is increasing. All right, if we make it negative x, we get the opposite, where left to right, it starts positive and it starts to decrease as we go towards the right. All right, again, I'm going to turn the negative ones off in this case because I want us to just be able to have a look at the positives just so you can see the trends. All right, now I'm going to turn x off as well for the moment because we're going to look at x cubed and I want you to be able to really see the shape. So if we go with x cubed, you can still see that just like with x squared, it starts on the negative and it moves towards positive as we go left to right. So again, this function is still increasing as we go from left to right, okay? But it has a bit of a bend in the middle, okay? And we call that an inflection point, a point of inflection. In Dutch, it's a buigpunt, okay? And you'll learn about that next year. All right, now that is x cubed, okay? If we don't go with negative x cubed, whoa, don't know what I did there. Let's try again. If we go with negative x cubed, then you can see it's just the reflection of that, okay? But instead it starts as a high number and it decreases as we go from left to right. All right, again, I'm not going to worry about the negatives for now because you can see the shape. I mostly just want you to be able to focus then on what happens as we go to higher powers. So x was a straight line. X cubed is a little bit bent. Okay, if we go x to the power of 5, then you can see the same thing happening as what happened with the parabolas. Actually, if you look closely at these functions in general, you can see that it's very similar to a parabolic function, okay, except that on the left side, instead of the function reflecting up, it bends down, okay? If you were to flip that around, if you were to twist that left side up, you would see it would look pretty similar to a parabola, okay? Now, x to the power of 5 gets a little more, squarish in the corners, and the arms get steeper. X to the power of 7, oh surprise, same thing. Okay, so this is happening exactly like it did with the parabolic functions. Okay, so back to our notes because we need to make some notes about this. What I want you guys to be able to get is that we get a lovely table here. Okay, and our table is going to look like this. Okay, so that we can take a closer look. I want you to be able to understand this summary. All right, we have fx equals a times x to the power of n. One condition is that a is either positive or a is negative. Okay, then our other condition is our values of n. So n can be even or n can be odd. All right, now if a is greater than 0 and n is even, so n even means something like x squared. Okay, x squared we know is a parabola, so we know we're looking at the parabolic shapes, and if it's positive, remember it's a happy parabola, so we've got a smiley face. So these are functions that look roughly like this, okay? And if a is negative, then we have a function that looks roughly like this. All right. If n is odd, that means we have something like x cubed. Okay, and remember we said if it's positive, then as we go from left to right, it increases. So that function is going to look like this. Okay, and if it's negative, it's going to just be a reflection of that. Where it goes from left to right, it decreases. Okay, this is the main thing we want you to get out of this lesson. There are two things I'm going to add, and these are things we're going to look at in more detail next lesson. Okay, that is this point here, which we've talked about in the past, in a parabolic function, is called the vertex. Okay, we're going to look at this in more detail next lesson. That's why I want you to really get this. So this is the vertex. Okay. Not just next lesson, sorry. We're going to look at this in more detail in 8.6. All right. Now, in a cubic function and beyond, in an odd function, this cannot be called a vertex, okay? Because a vertex is always a maximum or a minimum. So this is what we actually call a point of symmetry. Okay, and in the past we've talked about symmetry being a line. Remember, we said that a parabola has a line of symmetry, an axis of symmetry. This was an axis of symmetry. Okay, and in a cubic function and beyond, we actually have point symmetry. Okay, because if you fold it on itself, it doesn't actually come out the same. But if you rotate it around that point, so if you rotated this 180 degrees, you would see that it actually sits in the same position. So this has what we call point symmetry, and this is going to again be relevant when we get to 8.6. Okay, so this is the important thing for the moment. Okay, just make sure that you learn how this table works, okay, and that you therefore know what the shapes of the functions are depending on a or n.